Apple needs their permission to ship the next iPhone. NVIDIA needs their permission to ship the next AI accelerator. And in 2026, Intel needs their permission too. One Taiwanese company sits between every advanced chip on Earth and the customer who buys it. Most YouTube videos describe TSMC as the company that makes the best transistors. That misses what's actually happening. TSMC's real monopoly is not in lithography, it is in capacity allocation, in deciding who gets the wafers, in what quantities, and on what timeline. So in the next 13 minutes, I'm going to walk you through how that capacity allocation actually works, why Apple always wins the first node, why NVIDIA volume keeps growing anyway, and why Intel, the company that taught the world how to make chips, is now standing in line at TSMC like everyone else. First, the framing. The standard story about TSMC goes like this. They have the best lithography, the best yields, the best engineers. All of that is true, but it is not the moat. The moat is that capacity at the leading edge is finite, expensive, and slow to build. A new TSMC fab takes about 3 years and $20 billion to bring to volume production. Each new node, N3, N2, A16, is a separate set of fabs with separate tools, separate process recipes, and separate capacity ramps. So when N2 ramps in 2026, there is a fixed number of N2 wafers per month, somewhere around 40 to 60,000 at the start, ramping toward 120,000 by 2028. That number cannot be increased on demand. It is set by the building, by the EUV lithography tools from ASML, by the test capacity, and by yield learning curves. And demand for those wafers is not finite at all. Apple wants 30,000 a month. NVIDIA wants 40,000. AMD wants 10. Qualcomm wants 10. Broadcom, Marvell, the entire fabless industry, they all want N2. So TSMC does not just make wafers. They allocate them. And every customer in the leading edge industry is downstream of that allocation decision. That is what this video is actually about. Now, what does N2 actually deliver technically? N2 is TSMC's first full gate-all-around node. After 10 years of FinFET, the transistor architecture finally changes. The fin is replaced by a stack of horizontal silicon nanosheets, surrounded on all 4 sides by the gate. That gives you better electrostatic control, lower leakage, and higher drive current at the same voltage. Compared to N3E, you get roughly 10 to 15% performance at the same power, or 25 to 30% lower power at the same performance, and around 15% higher density. Those numbers sound modest if you have been following Moore's law for a decade. But there are 2 things to understand. First, every percent of performance per watt at this node is worth $10 billion of data center capex avoided. Hyperscalers are not buying chips by the thousand. They are buying them by the 100,000. So small improvements compound into very large dollar values. Second, N2 is also where backside power delivery shows up. TSMC calls it superpower rail, and it lands at A16 in 2026 and 2027. Backside power delivery means the power and ground rails are routed underneath the transistors instead of through the same metal stack as the signals. That frees up the upper metal layers for routing, reduces voltage droop, and gives you another 10% or so of performance at the same power. A16 is essentially N2 plus backside power. So through 2026 and 2027, TSMC's leading edge is N2 followed by N2P followed by A16. That is the playing field. Now let's talk about who is allowed to play first. Apple goes first. They have gone first on every major TSMC node since N7 in 2018. They go first on N3 in 2023. They go first on N2 in 2026. There is no public version of TSMC's customer ranking, but if you watch product launches, the pattern is unambiguous. Why does this happen? The first reason is volume. Apple buys roughly 20 to 25% of TSMC's total leading-edge wafer output year after year for over a decade. That is bigger than any single fabless customer in history. When TSMC plans capacity, Apple is essentially the anchor tenant. They fund the ramp, they validate the yields, and they smooth the transition from R&D to volume. The second reason is yield maturity. New nodes always start with poor yields. Apple's iPhone SoC is a relatively well-understood die, large but predictable, with mature design IP. Apple is willing to pay premium pricing during the early ramp when defect density is high, in exchange for the marketing advantage of being first on the new node. NVIDIA, AMD, Qualcomm, they would rather wait 6 to 9 months and let Apple absorb the early yield risk. The third reason is silicon design partnership. Apple's chip team works with TSMC's process integration team on physical design rules, on yield enhancement, on package compatibility. By the time the rest of the industry shows up, Apple has effectively co-developed the node. That is not collusion. It is just what happens when one customer commits to a node early enough and at large enough volume to influence the design rules themselves. The cost of catching up is real for everyone else. So Apple gets the first wafers. They pay a premium. They take the yield risk, and they reap the marketing reward. This pattern has been stable for 7 years, and there is no sign of it breaking. NVIDIA goes second, but here is the interesting part. NVIDIA's total wafer consumption in 2026 may actually exceed Apple's. The Rubin GPU lineup, ramping in late 2026 on N3 class, with HBM4, plus Rubin Ultra in 2027 on N2, plus the volume Blackwell shipments still rolling on 4NP, that adds up to a wafer demand profile that, in aggregate, rivals or exceeds Apple's. Why doesn't NVIDIA go first then, if they are buying that much capacity? Because Apple's design fits the early yield window better. Apple ships a single SoC at high volume across hundreds of millions of phones. NVIDIA's chips are larger, more complex, with HBM stacks that need their own qualification cycle. The co-OSL packaging adds another 2 months of lead time. So even when NVIDIA wants to be on N2, they have to wait until packaging capacity at N2 compatible CoWoS lines is ready. That waiting period is where Apple gets their head start. But the second mover position has its own advantages. By the time NVIDIA is ramping on N2 in 2027, the yields are mature, the defect density is down, the cost per good die is lower, and TSMC has had a year of learning to absorb. NVIDIA can therefore build out very high volume on a yield-stable node. So Apple gets the first node. NVIDIA gets the bigger node. Both are winning, just at different stages of the curve. This is also why NVIDIA's gross margin keeps holding above 70% even as wafer prices climb. The economics of being second on a leading-edge node, but at very high volume, with very high ASPs on the final product. That is a structurally great position. It is just one that requires waiting your turn. Now Intel. This is the part that should make you think. For most of the last 40 years, Intel was the industry. They made the best transistors. They had the most advanced fabs. They taught the rest of the world how to scale silicon. By 2015, that was no longer true. By 2020, they were 2 nodes behind. By 2024, they were trying to launch a foundry business of their own, Intel Foundry Services, and they were still failing to ship leading-edge volume on time. In 2026, Intel becomes a TSMC customer for some of their highest-end products. Lunar Lake, Arrow Lake, parts of the Gaudi AI line, large portions of Intel's 2025 and 2026 product roadmap are manufactured by TSMC on TSMC's nodes. Intel still has internal fabs, Intel still has 18A, but for the products where they cannot afford to be late, where they cannot afford a yield problem, where the customer has zero tolerance for a slipped roadmap, Intel went outside. Read that again. The company that defined leading-edge silicon manufacturing for 40 years now buys leading-edge silicon from a vendor in Taiwan, alongside Apple, NVIDIA, and AMD. The role reversal is complete. Will Intel come back? They have 18A ramping in 2026. The marketing materials say it is competitive with N2. The reality, based on early sampling and known yield data, is more nuanced. 18A may close the gap in performance per watt, especially with power via Intel's backside power delivery technology. But closing one node gap is not the same as catching up. By the time 18A ramps in volume, TSMC will be on N2P, then A16. Intel needs not just one good node, but 3 consecutive good nodes to truly return. That is a multi-year, tens of billions of dollars commitment, and the customer base is still skeptical. So through 2027 and probably 2028, Intel keeps standing in the same line as everyone else. So who actually wins, and why does this matter for everyone watching? TSMC wins through 2028. There is no credible alternative supplier for leading-edge logic at meaningful volume. Samsung Foundry has talent and ambition, but has stumbled on yield at every recent node. Intel Foundry has fabs but no proven external customer base at scale. The Chinese alternatives, SMIC most prominently, are blocked from EUV by export controls, capping them at roughly 7-nanometer class processes for the foreseeable future. What this means structurally is that TSMC sets the price for the leading edge, and every other player downstream, Apple, NVIDIA, AMD, Qualcomm, Intel, pays that price and prices it through to their own customers. TSMC's gross margin on N3 has run above 50%. On N2, with the GAA premium and the limited capacity, it will likely run higher. For Apple, the cost is acceptable because the iPhone supports it. For NVIDIA, the cost is acceptable because AI demand will pay anything. For Intel, the cost is acceptable because the alternative, being late to market, is worse. Everyone pays. TSMC takes a cut on every leading-edge chip in existence. There is one wildcard worth flagging. The fabs in Arizona are real. Fab 21 is producing N4 commercial volume in 2025. N3 is ramping there in 2026. N2 is committed for 2028. The capacity diversification is happening. But the politics, the cost premium for U.S. production, and the supply chain still flowing through Taiwan for advanced packaging, all of that means the structural moat does not move just because some fabs sit on U.S. soil. The moat is the integrated process, the equipment supplier relationships, the engineering depth, and the customer trust. None of that diversifies in 3 years. So the verdict, TSMC's monopoly is real, structural, and probably extends through the end of this decade. Every advanced chip you will see between now and 2028 was either made there or delayed because of them. If this was useful, subscribe. This channel is where the actual semiconductor industry view of the AI race lives, not the marketing slides. Next video, we go upstream of TSMC to the single point of failure that even TSMC cannot route around. ASML. Drop a comment with what you'd like broken down. Thanks for watching, and I'll see you in the next one.